Hello dear students, I Abhinav Negi welcome you all on faculty driven platform that is Resultant. Guys, in this session we will be doing the complete Poisson ratio guys from the zero level. What is Poisson ratio? How the questions came from this. Each and everything about the Poisson ratio will be saying. Okay, from zero level. Okay, so guys, those who are new here, let me introduce myself guys. My name is Abhinav Negi. I have done my MTech from IIT Delhi. Got All India rank 164 in 2012. You have to score a better rank than this. Okay, guys, if you want to connect me, you can connect me at abhinav@resultant.in, my mail ID, and also my Telegram group Civil by Abhinav Sir. Already more than 6,200 students have already joined this Telegram group. Guys, we have conducted the scholarship test from 27th to 30th of June. A huge response guys. Overall 3,756 students have appeared in this test. Okay, and what is the result? That we will be announcing tomorrow at 8:30 p.m. Okay, tomorrow at 8:30 p.m. we will be announcing the rewards. We will be announcing the result guys. Okay, everyone on the comment section guys, how is the Josh? Please let me know on the comment section. Okay, please let me know on the comment section guys. Everyone ready for the Poisson ratio? Everyone ready? Then let us start the session. Hi Vijay, how are you? Good evening all guys. Okay, so guys, let us start the Poisson ratio. Before starting the Poisson ratio, let me tell you from where the topic strength of material comes. Guys, there are two types of body. Either guys, I can consider a body to be a rigid body. Okay, either I can consider a body to be a rigid body, or I can consider a body as a deformable body. Whatever physics you have studied in your class 11th, laws of motion, gravitation, rotational, everything guys, there we consider the body as rigid body in class 11th, apart from fluid mechanics and couple of other topics. You consider the body to be rigid. Means, rigid body means, suppose this is a body and in this body you apply n number of forces guys. Okay, in any magnitude, any direction you are applying the force. And by application of force by any magnitude, any direction, if the position of 2 points, let us just say the 2 points are A and B, is not changing, neither they are coming together, neither they are moving closer, neither they are moving apart, nor the orientation is changing, the body is exactly like this, dimension not changing, shape not changing, the body is considered to be rigid body. And if by application of force these things are changed, the body is deformable body. So consists the body to be deformable body. So here, if you apply the force, the deformation will be there. In reality guys, this is the real physics. This is the reality guys. In reality, everything in this universe, every body is a rigid body, a deformable body. Rigid body is a purely assumption. Now you will say, sir, if this is a deformable body, if in reality it is a deformable body, there is no rigid body, then sir, this is a body. I apply the force on this, sir guys. By application of force, sir, the dimensions are not changing. By elongating it, dimensions are not changing. By applying the force, nothing is changing guys. Yes, it is changing. It is changing guys. It is changing. That change is not visible by our naked eyes. Good evening engineering staff. That change is not visible by our naked eyes. Everything guys, when you apply the force, the change is there, the length is changed. Apply the force, the length is changed. That change is not visible by our naked eyes. Okay, it's like you said in temperature change, the body elongation is L alpha delta T, or if temperature is reduced, the body will be contraction. So if I put the AC at 26 degrees Celsius and if I put the AC at 27 degrees Celsius, of course the length has to be changed, and it is changing. But that change is very small. Okay, so everything is a deformable body. Okay, sir. Now, sir, what is mu, sir? It is minus lateral strain by longitudinal strain. What is this, sir? What is this, sir? Poisson ratio. Let me tell you guys. Suppose this is a body. Acha, before going further, to make you understand the Poisson ratio, let me tell you whatever things I will be doing here. Every time guys, in I will be taking this x in this whole class. I'll be taking this as x, I'll be taking this as y, and this axis which is coming out from the board directly to your head, this axis which is coming to out of the board directly to your head, that is the z axis. Okay, so whatever things we are doing in the class, this is x axis, this is y axis, and axis which is coming out of mobile to your head, that is z axis. Okay sir, got it sir. Any doubt? No sir. Hi Ram, hi Vijay, everyone, welcome, welcome, welcome. Okay, now moving forward from here, let me tell you, before making you understand the Poisson ratio, let me tell you a couple of other things as well. Okay, see guys, tension I will be saying as positive in this whole class, compressive force or stress I will be taking as negative. Okay, in this whole class guys, elongation, if the length is increased, I will be taking it positive strain, and contraction I will be taking as negative strain. Okay, so this thing please do consider in this whole class. Okay, now suppose this is a body. In this body, suppose here some force is acting, and due to this force, suppose sigma x stress is there. Okay, due to force, suppose sigma x stress is there. Okay, now let it be even not going to stress. Okay, let it be some force, let it be some force here. Due to this force, there will be extension in this direction, x direction, but simultaneously, most of the times, not always, I will be giving you the reason why I am not saying always. Most of the times, if it is elongating here, it is contracting in other direction. If it is elongating here, most of the times, not always, what is that exception, I will be letting you know guys. If it is elongating here, it will be contracting here guys, in other direction. Okay, so guys, what is mu? It is minus lateral strain by longitudinal strain. Now sir, mu is equal to Poisson ratio is minus of lateral strain divided by longitudinal strain. Sir, what is lateral, what is longitudinal? Guys, first of all, the biggest myth that the bigger direction is longitudinal. No, not at all guys. The bigger direction is not longitudinal. The bigger direction is not longitudinal. The longitudinal is the direction where the force is acting. For this force, this is longitudinal. And the other two directions, y and of course in 3D, z, that will be the lateral. So guys, if the force is acting in this direction, of course this will be the longitudinal. So people think, students think the bigger direction is longitudinal. No, the direction of the force is longitudinal. For this force, this is the longitudinal. So here, mu is equal to minus longitudinal strain, that is epsilon x, because I have considered this as x direction, and the lateral strain is epsilon y. Guys, elongation I am taking positive, so epsilon x is positive, and this strain is negative, y strain, this is negative, and one more minus sign, so overall mu becomes plus most of the times. Also guys, longitudinal is epsilon x. If y is lateral, because y is perpendicular to x, z is also perpendicular to x, so z is also lateral, and one more minus sign, this one. Okay, this minus sign is this one, which is already in the formula by default, Okay, so from y is perpendicular to x, okay, similarly z is also perpendicular to x, so in x direction it is increasing, so here again it is positive, but in z direction it will be minus. Okay, so 1 minus 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 minus, it is plus, so mu mostly comes plus. Why? What are exceptions I will be telling you. Okay, so where the forces are acting, that direction is longitudinal direction, Now suppose where is the extra space? Okay, I am doing something here. Suppose this is a body, and this is the force acting. Okay, so here mu is equal to minus of lateral strain by longitudinal strain, so minus, which is in the formula. So here what is the longitudinal strain? Y direction, where the force is acting, that is the longitudinal direction, and x will be lateral. Okay, mu is equal to what is in this direction where force is acting, that is longitudinal. So minus is this minus is of the formula. and z is also lateral. So here in y direction force is acting, so y is longitudinal here, so x and z will be lateral. Now guys, see here in this direction, it is the length, it will be deformed, most probably it will be deformed like this. Okay, so in y direction guys, it is minus, and in x direction it is plus. So overall it becomes plus. Overall it becomes plus. So here y direction it is minus, it is decreasing here, and z direction it will be increasing. So minus minus, it will be becoming plus. Give me a yes or no, everybody on the comment section, guys. Everybody on the comment section, please give me a yes or no. Vijay, only Josh means concept you are not getting. Hi Ram, hi Sachin. Sir, Sachin sir, it is a tensor that I already told the students. Okay, stress is a tensor, guys, because yes, it has magnitude, yes, it has direction, but it doesn't follow parallelogram law of addition. Okay, I am considering with force P only. What Sachin, what Vijay you are saying? Shall I assume diameter to length of cylinder bodies are? Sir, shall I assume diameter to length for cylindrical bodies are? Diameter can be lateral also, yeah. Okay, I already told you the bigger direction is not the longitudinal direction. Okay, yes, this is the force acting, guys. So here in other direction it will be like here, if I am applying like this, so here it will be contracting, but other two direction it is increasing for compressive force. For elongation, guys, if I am elongating, so it is elongating here, but other direction it is compressing. If I am compressing here, guys, so here it is compressing, but other direction it is elongating. Okay, yes or no? Okay, if I am elongating here, it is elongating here, other direction it is compressed. Not always. Soon I am coming to the exceptions as well. But before that, going into 3D and everything, let us do a simple numerical. A bar of 40 mm diameter and 400 mm length. This is a bar. The diameter is 40 mm. Tell me the answers, guys. Tell me the answers quick. The diameter is 40 mm and length is 400 mm. Length is 400 mm, is subjected to axial load of 100 kilonewton. Is subjected to axial load of 100 kilonewton. It elongates by 0.150 mm. Of course, guys, when the force is applied, it is elongating. Okay, elongating means it will be tensile force. So it will be elongating like this. Okay, the length is increased by this, and of course the diameter will be decreased by this. What is the Poisson ratio? What is the Poisson ratio? So guys, mu is equal to minus of lateral strain divided by longitudinal strain. This minus is of the formula, divided by lateral upon longitudinal. Longitudinal is in the direction of force, so this is longitudinal. So here the length is increasing, 0.150 upon delta by L. So what is strain? Strain is change in length by original length. It is elongating, so it is plus. It is elongating, so it is plus. What is strain? Delta, change in length upon original length. In diameter is decreasing, so that will be minus strain. What is delta? Change in diameter is 0.005. 0.005 upon diameter. Diameter is 40. Diameter is 40. So what this value is coming, guys? Can you please let me know in the comment section, guys? Can you please let me know in the comment section, guys? Everyone, tell me. Tell me. बताओ. Okay, 0.33. Everyone is getting the same value. Okay, I am assuming that you are saying correct. This is the value. Okay, I am not going into the calculations. Now guys, mu of different materials are this. Mu of cork is 0. What is the significance of 0? I'll let you know. Mu of other materials are like this. Mu of polymers and human tissue is like this. Now what is important for you? That can become in, there are infinite materials. For infinite materials, you can't remember the infinite values now. So let me tell you what are the important values. This is important, and one more important, mu for ductile materials. All ductile is now in this category. Mu for ductile materials is from 1 by 3, that is 0.33 to 1 by 4 to 1 by 4 to 1 by 3. 1 by 4 to 1 by 3. Okay, so these three values you have to remember. One is this. There are infinite materials, you cannot remember the infinite values. So these three should be known. Now what is the, acha, one more thing. If ever in the competition exam, guys, in mechanical this has happened. So they ask one time, what is the mu, range of mu? And they have written mu of all substances in this word. So people have written, remember 0 to 0.5, 0 to 0.5, that is wrong. The correct option was, the maximum value is 0.5 for rubber and -1 can also be there for soap polymers. Okay, so apart from these three, this also you have to remember. Rubber, perfectly plastic material. Now, guys, what is perfectly plastic? I'll tell you, each and everything which is coming from my mouth. I'll let you know. Till then, forget perfectly plastic. I have not said perfectly plastic. What is perfectly plastic? I'll tell you after 20 minutes. This is the mu. This is asked in the mechanical. People have all ticked 0 to 0.5, 0 to 0.5, 0 to 0.5, 0 to 0.5. I guess it is 20 years back. This question has asked in GATE in mechanical. But the correct answer was -1 to 0.5. Then people remembered it is -1 to 0.5. Then again one more question is asked after 2 years. That time the GATE has given an answer 0 to 0.5. What is the difference? I'll let you know. What is the difference? I will let you know, guys. Guys, both questions are actually different. When they have asked, both questions are different. When they will ask the question in any exam, the value or the range of mu for all substances, the range of mu for all substances in this word, in the substance, guys, polymer and human tissue will also come. Then this is the correct answer. When they ask metals, guys, the negative mu is not for the metals. The negative mu is not for the metals, guys. For metals, the answer will be 0 to 0.5. For metals, guys, the answer will be 0 to 0.5. For metals, the answer, so both the times actually people are thinking they have given the different answers. No, actually the question was different. When they ask substance, it will be -1 to 0.5, and metals it is 0 to 0.5. Now, guys, 1, 2, 3, 4, 5, 6. 6 values you have to remember. Now, guys, sir, what is the significance of 0, sir? What is the significance of 0? Sir, I understood. Plus value I understood. Plus value I understood because, sir, usually if one is decreasing, other will be increasing. If this is increasing, this is decreasing. So if this is decreasing, this is increasing. So the formula, if this is plus, this will be minus. Otherwise, if this is minus, this will be plus, sir. So I understood that mu will be plus. Yes, mostly it will be plus. But there are some exceptions. Like for mu, cork, it is 0. Mu cork 0 means, guys, in wine bottle, guys, that is why the cork is used. Apart from the technicality of some chemical composition and wood is touching to the wine and making it better and better day by day. Apart from that, one more reason is that mu is 0 for this. Now, sir, what is the significance? Engineer star, everyone, good, Vijay. What is the significance, sir? For mu 0, sir, what is the significance? Guys, mu 0 means mu is equal to minus of lateral strain divided by longitudinal strain. If mu is equal to 0, that means lateral strain is equal to 0. That means when it is in the bottle, lateral strain is 0. When I am applying the force like this, or I am compressing when I was packing the bottle, compressing the wood here, or I am elongating this, so lateral strain is 0. So this is the longitudinal direction. So lateral strain will be 0 because mu is 0 now. If it is 0, then numerator has to be 0. Lateral strain is 0. That means the diameter is not increasing. If diameter is not increasing, the bottle will not break. If it is not compressing, so air will not go down. It will be airtight. Understood, guys? Tell me. Put a heart sign on the comment box if you got it. Put a heart sign on the comment box if you got it, guys. Put a Hertz and incompressible condition. I'll be telling you are along with the perfectly plastic material. I'll be telling you the incompressible condition as well. Tell me guys, why cork is used in the wine bottle? Of course, there are some chemical relations also. That wood touching the wine will be making it better and better. But apart from this, one physical or according to physics, one more reason, because lateral strain is 0. That means diameter is not increasing, so it will not be cutting the bottle, not breaking the bottle, not breaking the glasses. It is not contracting, so it will be airtight. It will not go down. Why? How it is 0? I'll tell you that. Now mu negative. Guys, if you see this paper, then I am applying the force. It is increasing in this direction also. It is increasing in this direction also. So mu is equal to minus of lateral strain upon longitudinal strain. So both are positive. Minus, this is also positive, this is also positive. So net value is negative. Net value is negative. Because it is increasing here. So denominator also positive, numerator also positive. So net value is negative. So sir, how this is here? How this is, sir? How I am not getting this, sir? That how both is increased? Guys, mu can be 0, can be positive, can be negative. When I am saying that human tissue and I am applying the force like this, and by application of force it is increasing here, it is going like this. So you are not accepting, sir, how this is? For this mu is negative, sir, because mu is minus of lateral by longitudinal. Lateral is also positive, longitudinal is also positive. So one more minus sign, it will be negative. Let me understand you again. Mu is equal to minus of lateral strain by longitudinal strain. So here mu is equal to minus lateral strain also positive, longitudinal strain also positive. So net is negative. So sir, I'm not getting this, sir. How this possible? Guys, there is a wrong concept in your mind. There is a wrong concept in your mind that volume has to be constant. You are not accepting this. You know why? Because you think that volume has to be constant. Let me tell you guys. Here also volume is not constant. Here also volume is not constant. I'll prove it in this class only. Here also the volume is not constant. But you're not, as we have not derived the formula of volume till now, so you are accepting, okay, this happened. Why your brain is not accepting this? Because you think volume has to be constant. Guys, first of all, this is a deformable physics, not a rigid body physics. In rigid body physics, volume has to be constant. Here the volume can change. Second, let me tell you more in microscopic level. In microscopic level, guys, let me tell you, human tissue and polymer, if you see from microscope, human tissue and polymer, guys, certain chemicals or certain atoms are attached like this. These are hinges. If you see from microscope, these are hinges. These are hinges like this. These are hinges like this. Okay, these are hinges like this. Now in this hinge, if I apply the force like this, so this hinge will open, na? This hinge will open, so it will be like this. Hinges are open, na? So if I apply like this, so both sides it will be open. Here also it will be going, because this will become straight. Okay, so they will go like this also, they will go like this. So in both directions the length is increasing in human tissues. And human tissue, if you see from microscope, the different molecules are attached through hinge. And when you are applying the tensile force to the hinge, both are increasing. Give me yes or no in the comment section, like this. Give me yes or no in the comment section. Yes, for Bhopal it is good for the preparation, guys. Not, see, NIT is not very good for the placement. If you see Bhopal or any other, apart from Trichy, Warangal and Allahabad, and couple of more, Suratkal and Calicut, not very good for placements. Okay, but yes, for preparation it is good, and it is not top of the NITs, but yes, it's average. Give me yes or no. Have you understood this? Now let me go for the uniaxial loading. Now let me go for this uniaxial loading. Okay, suppose this is a bar. I am again saying guys, in whole this class I am repeating this. This is x direction, this is y direction, and the axis which is coming out of the board, axis which is coming out of the board directly to your head, that is the z direction. Okay, tension I am taking as positive, compression I am taking as negative, elongation I am taking as positive, contraction I am taking as negative. So guys, if in this body some stresses or forces are coming, due to which some stress will come, forces are coming due to which some stresses come, sigma x, unidirectional loading, only one direction, only one direction. Okay, only one direction. Now what is mu? Mu is equal to minus of lateral strain divided by longitudinal strain. Longitudinal does not means the bigger, longitudinal means where the stress is acting. So here the stress is acting, so this will be the longitudinal, guys. So here the longitudinal strain is epsilon x, and minus lateral strain is y, and as y is perpendicular to x, so is z is also perpendicular to x, so minus epsilon z upon epsilon x, correct? So from here guys, everyone, mu is equal to this. Okay sir, so epsilon y is equal to epsilon z is equal to minus mu epsilon x. Now guys, stress by strain is equal to Young's modulus, but only in case of unidirectional loading. You can write sigma x by epsilon x is equal to Young's modulus. Many of the students, unfortunately some teachers also, doesn't know that this is only for unidirectional loading. You cannot apply, if suppose load is acting like here on sigma y, then you cannot write sigma x by epsilon x is equal to Young's modulus. Stress by strain is equal to Young's modulus only in case of unidirectional loading. Okay. So here sigma x by epsilon x is equal to Young's modulus. So what is epsilon x? Sigma x by E. Okay. So what is epsilon y here? Minus mu epsilon x, minus mu sigma x by E. What is epsilon z? Minus mu sigma x by E. What is epsilon x? Sigma x by E. Give me yes or no, please. Give me yes or no, please, guys. Come on. Come on, come on, come on. Come on. Come on. Yes, विशाल प्लीज सी. यार इतनी मेहनत से हम वीडियो बनाते हैं, आप देखते नहीं हो, है ना. मैंने पूरा एक वीडियो बनाया है जिसमें मैंने लिखा है कि ब्रांच कैसे चूज़ करते हैं, कॉलेज कैसे चूज़ करते हैं, सारी चीज़ें उसमें बताई हैं कि स्ट्रक्चर क्या क्या मतलब है, जियो इन्फॉर्मेटिक्स का क्या मतलब है, सारा चीज़ उसमें बताया. 3 बार टेलीग्राम में लिखा है ना. 3 बार टेलीग्राम में लिखा है. एक बार पूरा इतना लंबा पैराग्राफ खुद टाइप करके डाला था. एक बार इतना लंबा पैराग्राफ खुद टाइप करके डाला था कि कैसे चूज करना है ना. आजकल इतने लोग यूट्यूब का लिंक डालने लग गए टेलीग्राम पर कि बस बच्चों को लगता है कि बस ये तो यूट्यूब का लिंक देख लेंगे तो टीचर का फायदा हो रहा है, हमारा तो नहीं हो रहा. टीचर का फायदा हो रहा है, हमारा तो नहीं हो रहा. अगर आप वो देखते तो पूरा डिटेल में आपको पता चलता है कि स्ट्रक्चर का क्या मतलब है, क्यों स्ट्रक्चर लोग ज़्यादा पसंद करते हैं, क्या स्ट्रक्चर हमें फर्स्ट ऑप्शन भरना चाहिए, किस केस में हमें ब्रांच प्रेफरेंस करनी है, किस केस में हमें कॉलेज प्रेफरेंस करना है. अच्छा ठीक है, आप लोगों को लगता है कि यूट्यूब से तो टीचर का फायदा है, हमारा क्या फायदा है भाई, हमारा क्या फायदा है यूट्यूब से, तो टीचर का फायदा हो रहा है, उसको लाइव काउंट मिल रहा है. मत देखो यूट्यूब. मैंने तो पूरा पैराग्राफ में भी लिख के टेलीग्राम पे दिया था कि किस चीज़ का क्या मतलब है. आज फिर से रात को अभी जरा एक दो मीटिंग होंगी, कुछ काम होगा, जब मैं फ्री होऊंगा तो फिर से लिख दूंगा ना। यूट्यूब में मत देखना, यूट्यूब में तो क्योंकि लोगों की मानसिकता बन गई है कि तो टीचर का फायदा है, हमारा थोड़ी नहीं। टीचर टेलीग्राम में डाल रहा है, उसमें कर रहा है ना। तो मैं आपके लिए फिर से वो पैराग्राफ दे दूंगा, आपको पूरा समरी मिल जाएगा। लेकिन ऐसा आप लोगों को अपने से पूछना पड़ेगा कि इतना ज़्यादा स्पून फीडिंग आज की डेट में हो गया है टेक्नोलॉजी आने से, कि टीचर पहले तो बोलेगा कि आपको आओ, फिर लाइक करो, सब्सक्राइब करो, फिर कल का शेड्यूल बताएगा। फ्री वाला ही, पेड वाला तो कुछ बोल ही नहीं रहा भाई, पेड वाला तो बोल ही नहीं रहा, फ्री वाला है कि कल एक और यूट्यूब क्लास होगी, फिर ऐसा होगा। पनामा कैनल का एक बेहतरीन वीडियो मैंने बनाया, जो बहुत सारे इंटरव्यू पूछते, अभी संडे का फंडा में लगाया था मैंने, लेकिन बच्चों ने इतना देखा ही नहीं, कितना मेहनत करके लगाया था। ठीक है, चलो कोई बात नहीं। अच्छा, नाउ गाइस, दिस ट्रेन्स एप्सिलॉन x, एप्सिलॉन y, एप्सिलॉन z, I can think in like another way also. Guys, value of mu is less than 1, of course less than 0.5. So I can think it like that also, guys. Epsilon x is sigma x by stress by Young's modulus. Unidirectional loading, strain is equal to stress by Young's modulus. Okay. Epsilon y and epsilon z, if this is elongating, this is plus, so this will be minus, so minus signs are coming. Of course, if this value is minus, then with this minus it becomes plus. If this is minus, with minus it becomes plus. So, okay, the sign of this is different, the sign of this is different, because minus is coming here. If this is positive, with this minus, these are becoming minus. If this value is minus, with one more minus, this become plus. So anyhow, this is different, this is different. Okay, correct, yeah. Correct, yeah. If it is elongating in one direction, other direction it is compressing. We are studying for metals, guys, in strength of materials, not human tissues and polymers. Okay, so strain is equal to stress by Young's modulus. But in other, guys, if I apply the force like this, here it is elongating, if I apply the force like this, here it is elongating, but here it is contracting, but the magnitude of the elongation will be more na, and magnitude of the contraction will be lesser na. Of course, guys, if I am applying the force here, that is the longitudinal direction, the magnitude of this elongation is more na, and the magnitude of this contraction will be less. Lateral strain has to be less, guys. Of course, mu value is less than 1, so this is smaller, this is bigger. Okay, so guys, in one more way, you can see this is bigger and these are smaller. Why this is negative sign? I told you, because if it is elongating, this is contracting. Sign has to be different for metals. And why mu is there? Because, guys, the magnitude of this has to be more, longitudinal strain has to be more, and this has to be lesser by mu times. Understood, guys? By this way also you can understood this. Okay. Now for multi-axial loading. Guys. If this is x, this is y, and the axis which is coming to you is z axis. This is x, this is y, and the axis coming to your head is z direction, guys. Okay, tension is positive, tensile stress is positive, compressive stress is negative. Elongation, increase in strain is positive, contraction is negative, guys. Okay, sir. Got it, sir. I got it, sir. Now, 3 directions. Let it be a body. Let it be a beautiful body like this. Excellent, guys. And in this body, stress is coming here, sigma x. Of course, in this direction also coming. I am showing only in what direction. This is sigma y. And this is sigma z, guys. I am telling you, if you just watch me, for next 12 to 15 minutes, guys, you will be master in this concept. You will be master in this topic, guys. Okay. Now, everyone, everybody, every commando, every champion, please see here, guys. If I want to write strain in x direction, okay, then I will write strain in y direction, then I will be writing strain in z direction. Okay, guys. Now see strain in x direction. guys, here for multi-axial loading, stress sigma x by epsilon x is not equal to Young's modulus. Sigma x by epsilon x is not equal to Young's modulus here, because stress by strain is equal to Young's modulus. Stress by strain is equal to Young's modulus only in case of uniaxial loading. Stress by strain is equal to Young's modulus only in uniaxial loading. Okay, sir? Got it, sir. Now here epsilon x. When I am writing epsilon x, forget these two. Forget these two, guys. Hit them. Hit a bullet. Only sigma x. Due to sigma x, only in one direction, sigma x stress is acting. What is the epsilon x? Stress by Young's modulus. In unidirectional, guys, I can apply this. If I delete this for a minute, due to sigma x, what is the strain in x direction? Sigma x by E. Now delete these two. Due to sigma y, strain in y direction will be sigma y by E. Due to sigma y, strain in y direction will be sigma y by E. Na? Delete these two. But in x direction, the strain will be lesser. Na? Delete these two, guys. If you delete these two, now y becomes longitudinal. X and z becomes lateral. So due to sigma y, strain in y direction will be sigma y by E. But in x direction, it will be lesser. How much lesser? Mu times. And if it is positive, so this has to be negative, na? Because, guys, if sigma y, it will be, if sigma x is like this, na, it is elongating, na. In x direction, it is elongating, na. So it is plus, na, yaar. In y, due to y, delete these two. Due to y, if I am elongating like this, 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 x will be contracting, na. Due to this sigma y, yes, in y direction it is elongating. In y direction it is elongating. But due to this, in x direction it will be compressing, na, yaar. So in x direction it will be like this. Similarly, due to z, now delete these two. Due to z, if I am elongating here, so in x direction it will be decreasing. Mu times. Understood? Not understood? Now see this. Due to sigma y, what is the strain in y direction? Delete these two. Only one direction stress. So strain is equal to stress by Young's modulus. Now delete these two. Due to sigma x, strain in x direction is equal to sigma x by E. But in y direction it is Poisson effect, na? Mu times, na? So due to sigma x, stress in x direction is sigma x by E. But due to sigma x in y direction, it will be minus mu sigma x by E, na? Of course, guys, if due to this sigma x it is elongating here, in y direction it will be compressing, na, yaar? In y direction it is compressing, na? Similarly, due to z, it will be minus mu sigma z by E. Similarly, this will be sigma z by E minus mu sigma x by E minus mu sigma y by E. Give me yes or no. Give me yes or no on the comment section, guys. Everyone. Give me yes or no. Please, guys. Come on. Hit me a yes or no. Hit me a yes or no, please. Hit me yes or no, please, guys. Are you getting this, guys? Are you getting this? Please let me know. Yes or no. Now, guys, everyone, please see here. Please see here. For this figure, it is like this. Now let me make different figure. Okay. Now yellow color is there. Okay, let me do orange color. Suppose, guys, this is a body. This is sigma x. This is sigma y like this. This is sigma z like this. Now, guys, I want to write strain in x direction. I want to write strain in y direction. I want to write strain in z direction. Two ways. First way without any technique. Take these formulas as reference and apply the formulas here with silent convention. Okay, first way, take these formulas as reference. Sigma x by E, sigma x is tension, okay, fine. Minus mu sigma y by E, minus mu sigma y, but sigma y is in compression, it is minus. So minus mu and minus sigma y plus mu sigma y by E. Similarly, minus mu sigma z. Take this formula as reference and apply sign convention. Minus mu sigma z. So minus mu and sigma z is also minus. So minus mu minus sigma z will be plus. Plus mu sigma z by E. Okay. Now this is by formula. Now other way is by a logic. Logic is straight in x direction, leave these two, due to sigma x it will be sigma x by E. Leave these two, due to sigma x it will be sigma x by E. Now leave these two, due to sigma y in x direction it is mu times. Due to sigma y in x direction it is mu times. So mu sigma y by E. And apply the logic. If it is compressing here, so it will be elongating here plus. Similarly guys, if z, apply the logic. Due to z in x direction, due to sigma z in x direction, it is mu times mu sigma z by E. And if I am compressing here, it will be elongating like this. Now these two you can do. These two do from the both methods. From here, applying, let me tell you one more. Then third one you can do homework. Now the first method is apply this formula. Sigma y by E, sigma y is in compression. Take this as standard result and apply the sign convention. Sigma y by E, but sigma y is compression. So minus sigma y by E. Minus mu sigma x by E, minus mu sigma x by E. And minus mu sigma z, but sigma z is minus. So minus mu minus sigma z, it will be plus. Plus mu sigma z. This is by, this take as a homework. This is by this. Second way, logic. Due to sigma y it is compressing na, so minus mu sigma y by E. Due to sigma x in y direction it is mu times mu sigma x by E. But if I am elongating here, in y direction it is reducing, so minus. Due to sigma z it is mu times, so mu sigma z by E. But if I am compressing here, in y direction it will be increasing, so plus. Give me yes or no. Have you got it or not got it, guys? Have you got it or not got it? Hi Krupa. Krupa, I'm your brother or teacher. I am your brother or teacher. Everywhere you are writing these days. It's okay. It's okay. You can write anything. Got it? Enjoying, guys? Enjoying? Okay. Now, volumetric strain. Of course, guys, strength of material is a deformable physics. Strength of material is a deformable physics, guys. Here volume will be changed. Okay. Suppose there is a cuboid of L, B and D. What is the volume? LBD. What is the change in volume? Change in volume is written as delta LBD, delta BLD, delta DLB. And if you have a strong imagination, everybody will be telling you like this. Book will be telling you like this. If you have a strong imagination, guys, I will prove this also. Otherwise, guys, in every book it is written like this without any supporting statement. Every teacher is telling like this without supporting statement. If you give me some 2 minutes, guys, 120 seconds, and if you promise me that you will imagine like anything with full concentration, I'll prove this also, how this comes. Guys, when I apply the force, stress, everything, suppose here the length is increased. So what is this extra volume? Delta L and cross-sectional area is BD, na? Delta L and cross-sectional area is BD. So that is the extra volume. Okay, got it. Yes. Similarly here. Delta D, this is delta D, and what is this area? LB. Similarly, for this side, it will be like this. Understood? Now you understood. And volume is LBD. volume is LBD. So what is the volumetric strain, guys? From here, volumetric strain is change in volume upon volume. Change in volume is delta LBD, delta BLD, delta D LB upon LBD. From here, guys, volumetric strain is delta L by L, delta B by B, delta D by D. So volumetric strain is equal to epsilon X plus epsilon Y plus epsilon Z. Delta L by L, epsilon X, epsilon Y, epsilon Z. And if you add epsilon X, epsilon Y, epsilon Z, E will be common. Okay. So it is 1 by E. If I take 1 by E, if I take sigma X plus sigma Y plus sigma Z common. Okay. So sigma X is alone coming 1, Y alone coming 1, Z alone coming 1. So one time they are coming alone. But with mu, sigma is coming 2 times, 1 and 2, 2 mu. With Y alone coming 1, but with mu 2 times, 1 and 2. Z alone coming 1, but with mu 2 times. So 1 minus 2 mu. Understood or not? Understood or not, guys? This is the volumetric strain. And when this volumetric strain comes na, sigma X plus sigma Y plus sigma Z 1 minus 2 mu upon E. What does this mean? If mu is 0.5, then volumetric strain is equal to 0. That is for rubber. For rubber, mu is 0.5. Volumetric strain is 0 because 1 minus 2 into 0.5, 1 minus 1 is 0. Okay, so rubber volumetric strain is 0. Rubber. And guys, for perfectly plastic material are those where volume is not changing. That is why for perfectly plastic also mu is 0. That is why mu is 0.5. Because for mu 0.5, volumetric strain becoming 0. And for perfectly plastic material are those material where volume is not changing. Therefore, for those material, volume is not changing when mu is 0.5. Therefore, for those material, mu is also considered as 0.5. Now, when you see mild steel, this graph. So here it is plastic region. Okay, here it is plastic. Here also mu is 0.5. Volume is not changing in this region. Length is changing, but other dimensions are decreasing such that no volume change. So in this plastic region also mu 0.5. Now you will say, sir, this is a rubber. I fill the air. It becomes like this. So volume is changing. This is the rubber. I fill the air. Volume is changing like this. Guys, this formula is for material. Material volume here, this material. And this material is same. I am not saying the inside volume. The inside volume you study in thin pressure vessel chapter. Thin cylinder, thin sphere. So volume of material is same. Yes, the surface area is increased by filling the air, but thickness of membrane will decrease, na? So this formula is not for the inside space. This formula is not for this space. This formula is not for this space. This formula is for material. Material is not changing. Even you fill the air, material volume is not changing. Or one more case. If mu is not 0.5, suppose mu is 0.1, but forces are like 10, 20 and 30. So sigma X is minus 10, sigma Y compression, so minus 20, sigma Z tension plus 30. So here also it is 0. Here also it is 0. So two cases where volume changing is 0, either mu 0.5, or sigma X plus sigma Y plus sigma Z is equal to 0. Okay, now tell me the sigma for which volume is mu is suppose 0.3. So tell me the value of sigma for mu for volume is not changed. So of course mu 0.3 na. So the volumetric strain is sigma X plus sigma Y plus sigma Z 1 minus 2 mu by E is equal to volumetric strain delta V by V. So here guys, this value is not 0. So this value has to be 0 because Young's modulus is a definite value. So sigma X is 175, sigma Y is 50, sigma Z is compression. So minus 22.5 sigma is equal to 0. So from here value sigma is equal to 10. Got it? Okay, Krupa, thank you. Got it, guys? Everyone? Okay. I hope you enjoyed Poisson ratio, guys. Soon I am coming with this. Now guys, on Monday, Thursday I am coming with soil classification. Remember for always, 8:30 p.m. Okay, my YT schedule. I guess Saturday I am coming with phi index and W index concept. Phi index and W index concept. That is again 8:30 p.m. That is again 8:30 p.m. Thursday and Saturday. Thursday and Saturday. Okay, guys, if you want to enroll in the courses, then you can enroll 1 year and 2 year course. Okay, sure, Krupa. Okay, 1 year and 2 year course. 1 year is 24,999. Okay, live and recorded classes are there. You can watch the class live. Again, you can watch infinite number of times recorded. Study notes are there. PYQs are there. Doubt sessions are there. Complete test series is there. Okay, study notes, PYQ, doubt, complete thing is available there, guys. Complete thing. Okay. Now for 26 batch, price is 3199. Of course, some discount is also going on. Live classes, study notes, PYQ with solution, PDF, weekly tests, complete test series exactly like GATE platform. Complete test series exactly like GATE platform is there. So either you can enroll in 1 year course, Vision 25 or 26. Test series, notes, everything is there, guys. Workbook, study notes, complete. Nobody is giving study notes across the country. Okay. Similarly for mechanical, guys, similarly live classes, recorded, PYQs, doubt, everything is there for 1 year 25, for 2 year 26. Okay, everything is available, guys. Complete mechanical team of Byju's is with us. Similarly, complete mechanical team of civil is also with us. Complete civil team of Byju's is with us. Okay, you can download the app, guys, from the Play Store. You can download the app from the Play Store. Okay. Play Store, you can write Resultant Civil or Resultant Mechanical. Okay, so this app will be there. If you want to connect us, this is the number, guys. This is the number for mechanical students. For civil students, guys, you can connect me here, 93549 the WhatsApp number, or you can connect me here in my email ID for any courses, discount, anything. Okay, so this is anything you want to connect about courses. Okay, any inquiry you have, you can connect us here, guys. Okay, civil students here, mechanical students here, or civil or mechanical both can connect us here. Okay, thank you, guys. I hope you enjoyed. Okay, so tomorrow scholarship result will be announced. Tomorrow, guys, scholarship result will be announced. Okay, at 8:30 p.m. Okay, at 8:30 p.m. we will be announcing the scholarship test results. Okay, enjoyed the class, guys, everyone. Thank you, guys. Take care. See you soon. For any other query, please let me know in the comment box. And yeah, watch Sunday ka funda, yaar, Panama Canal. Sunday ka funda. Panama Canal is there. Panama Canal. Beautiful video I have made here along with the experiment. Please watch this. Web is will making it in a few days. We'll be constructing this. Till then, you can connect us on app or these numbers. Okay. Thank you, guys. Take care. Thank you all.